Problem 1, apply the square foot cost estimate to a daycare center. So estimate project cost of a daycare center with the 85 feet wide, 170 feet long, and 15 feet high to be built in Tampa, Florida, 2015, using the IS mean square foot cost. The exterior wall is stucco on concrete block. The following are addition to the current daycare center compared to the model daycare center. This is additional. Basement of 10,000 square feet. I just make some adjustment just to demonstrate, but by no means you have a daycare center in Tampa, Florida that have a basement. Make sense? So just want to demonstrate how to make adjustment given different condition from the new facility, new daycare center with the reference model daycare center. Gym floor including slippers and finishes maple throughout, and then additional 150 smoke detectors. So like I said, to demonstrate how I use information from the IS mean to adjust for different parameters that different between the new facility, new daycare center, and the model daycare center, and that can be applicable to any other type of facility that we have. So with the square foot cost estimate, we go back here to review what other processes should be for this estimate. The first, we obtain the project data, approximate size of the daycare center, obtain the square foot cost data, and then we make adjustment. So let's do that for problem 1 in here. The first step, of course, we need to project data. And for this one, they already give us, so we can be able to get that one easily. So we have W. The width of this one is 85 feet. And of course, we have the length equal to 170 feet. And then the height of the daycare center is 15 feet. So from that, we can have the areas of the daycare. A equal to W times L. So we have 85 times 170. So we have 14,450 square foot. And then we have a perimeter. P is equal to, you see a rectangle, so you have 2W plus L. So you will get W 85 plus 170 times 2, so you will get 510 linear feet. So that is the basics project size of this daycare center built in Tampa. And then the next step, we need to get the square foot cost data, and the problem gives us IS mean, and that reference in the slide number 7 and to number 8. So we have that one here with square foot cost data, and that will be at IS means. And in this case, it published in 2008 the data that we have, and that go to slide. We will go refer back later on, but we have slide number 7 to 9. 7 to 9, that you have that one to use for this. And then now move on to the next step, adjustment and presentation. So what should be to do the adjustment? We go back to the slide in here, and you see from the model daycare center from the IS means, and as you can see, the top row is square foot area in square feet, and then perimeter in linear feet for the model, and it different exterior goal in the first column. And for us is the project is stucco on concrete block, and that you have that information here for that one. And our project have the square feet for the areas is 14,450, and the area, the perimeter is 510. We just did that in step 1, so it's somewhere in the middle between the 12,000 and 15,000. So in here. So basically the cost for this without adjustment is somewhere in this middle, and that somewhere 126 and 122.65 dollar per square foot. So easy. If you can do with the conservative, get the unit cost 126 dollar per square foot, or you do the interpolation between the two, or you pick somewhere in the middle, because given that in the middle. So it's, as you can see at the estimate, the accuracy level for this one is plus minus 15% accuracy. So you pick somewhere the middle, it should be good, or even conservative $126 per square foot. And if you prefer math, you want to do interpolation, and I'm going to show that to you, but like I say, I don't require you to do that, to pick the number between those two that makes sense to you to do the estimate, because this is the estimate, not exactly the actual cost that need to be. So with that, let me do the interpolation, but like I said, you can pick any number and it will be acceptable. You will get 100% if you get the number between 126 122. So with that, we can do the interpolation just for demonstration. If you love math, on engineering love math, I make that assumption. So you have the square foot cost before adjustment, and that it equal to with that interpolation, the number we have that here, and that it will equal to $126 plus with adjustment for the areas. The actual area is 14,450. We did about the models for the 126 12,000 in the slide I show you, and up to the next level is 15,000 square feet minus 12,000 square feet. And then the cost difference between from the model daycare center, 15,000 is $122.65 minus for the 12,000 $126. So from that we get this one is 123.26 square feet. So the square foot. So that what you have for interpolation, or you can pick between 123 126. It should be fine for that. Okay, so that either before adjustment, and then we need to make adjustment for the perimeter, different, etc. Now go to the perimeter, and why we need that perimeter. Adjustment. And for the perimeter adjustment, we need to determine the linear perimeter for the model building. So linear feet. First, we need to know the linear feet perimeter for model building, model daycare center with the the areas equal to 14,450. Again, we can do the interpolation, but just to demonstrate for you to see that here. You go back there, go back to the slide here, and you can see 12,000. The perimeter for the model daycare center of 12,000 square feet areas is 480. If it's 15, 510. So what should be the perimeter for the model daycare center with 14,450 square feet, the one that we want to build? So from that we can do some interpolation exactly similar to the previous equation. We have that if for 12,000 square feet daycare center with 480, and adjust for the 14,450, exactly the same equation about, divide by 15,000, interpolation fully, and then time for the model perimeter for the 15,000 square feet daycare center, 520 minus 480. So you get that is 513 square feet. 513 square feet. So that is the model perimeter if you expect to build 14,450 square feet area daycare center. So, and the question is why I need to do the perimeter adjustment? Why I need to do that? So let me show you the two scenarios here why we need. So suppose we have any facility, let's say a daycare center like this, and we have this one. Let's see that one side 100 feet, the other side 100 feet. So the daycare center, the first one is a square footage, and now I have another daycare center that have the shape a little bit different. So it will be 100 one side, and then we have 50. We have 50 here. We have 100, and of course that will be 50 in the bottom, and this will be 150 feet. So tell me, what are the areas of each of the daycare center here? The 100 times 100, it will be 10,000 square feet. Believe it or not, the other side also 10,000 square feet. So both in terms of square feet are the same. But which one, in your opinion, is more expensive to build? Think about it. Absolutely the right one, right? Because the perimeter, as you can see for the perimeter here, so we have for this one we have A equal to 10,000 square feet, and perimeter of this one is equal to 400 linear feet. This one we have A2, it's still 10,000 square feet, but perimeter for this it will be 50, 50, 100, 200, 200, 300, 300, and 200, so 500 linear feet. And you have more perimeter, it means you need to more windows, etc. And more windows, it means more, it costs more. So that's why we need to adjust for the perimeter. Just think about the you see the homes hall for the fourth floor, or glazing throughout, but then go to the third and the second floor. The faculty should have smaller windows, so that we call value engineering, reduce the cost. Otherwise, everyone prefer a bigger window. We have a wide view to see what's going on outside. And that because of the try to cut the costs, that sometimes compromise, and that, as you can see, parameter it play a key role in terms of the the cost of the buildings. That's why we adjust. So yes, in the model building, it have thin. So you see that, and then our perimeters is 510. So compared to that, let's go back to here. You can see that the parameter adjustment for parameter here is almost nothing, because we have only $4 for every 100 linear feet. We only have 3 linear feet difference, so it's almost zero, because you have like 4 times 3 divided by 100. It's very small, so you can ignore that as well. So in that case, as you can see, it here very close to, very similar to 5p 510. This is linear feet. So we don't need to have adjustment, because that is about the same, only 3 feet difference. It not make a big deal for the whole daycare center, so no adjustment required. If it's like 100 linear feet difference, then we have to make adjustment, and adjustment based on the table we have earlier. So that is the adjustment for perimeter. We don't need that. And then we continue with the story height adjustment. And for the story height adjustment, as you can see here, so they go back to the daycare center. This buildings, the model buildings, is 12 feet, and the story height, that is the column here, for every feet different, you have to adjust for story height. We have 15 feet height. The model buildings is 12 feet height. Then we have to adjust that. In the model, you have to see the height of the model buildings. Okay. So with that here, story height adjustment, so we adjust for something between 15 feet of the new versus 12 feet of the model. So from that, we can do the adjustment, and that the number is somewhere between these two number. So let me pick that is $0.87 per linear feet height. So we can make that call without doing interpolation again. So we can do the I can say by interpolation. So we can have 1.87, and we have the 15 minus 12, so that is the difference in height. So we have 261 per square foot. So from that, we can have the square foot cost after height adjustment. Square foot cost after height adjustment, and we have to add all of them together. So we have that one here, grab here, 123.26 plus 0 for parameter. This is a perimeter adjustment that we explained earlier, plus the adjustment for story height 2.61, and from that we have 125.87 per square feet. So from that square foot we can continue to determine the project costs in the next video to continue with this problem.